Alan and Quaichon are playing a game. They choose a real number at random between -1 and 1. They then add the squares of their numbers together, and if the result is greater than or equal to 1, Alan wins. And if the result is less than 1, Quaichon wins. What is the probability that Quaichon wins? This problem is a probability type problem. However, unlike most of the probability problems that we encounter in math competitions, this one does not involve discrete numbers, meaning the variables involved are not countable. For example, if we are solving problems involving choosing the selections of several members from a set of number of people, then the number of possibilities is finite and we can count them through combinatorics technique using permutations or combinations, whatever is applicable between them. However, in this case, we're dealing with all real numbers between -1 and 1. This variable is known as continuous. There are infinitely many numbers between -1 and 1, and we cannot count them for the purposes of finding the probability. In this type of problem, the general solution is what we call the geometric probability. We will calculate the probability by means of interpreting the situation using geometric concepts. In this case, let us consider X to be the choice of Alan, the number being chosen by Alan at random. Then Y be that choice for Quaichon. Since we are choosing both of them from -1 to 1, we can make an axis for this one, actually a coordinate system, where the horizontal axis is, let's say, the X, which represents Alan's number. So let's say this is the axis that we make for Quaichon. This is the y-axis. Sorry, what happened? This is the y-axis and this is the x-axis. The y-axis is for Quaichon. The x-axis is for Alan. Since we are restricting both of them to the set -1 to 1, we can set a bound here from -1 to 1 on both axes. So essentially, what we're doing here is we're restricting all points within this box here. So this box here is where we are only allowing the variables to be chosen from. For example, if we pick a random point from this box, let's say this point could be, let's say, 0.2, 0.5, which means that the number picked by Alan is 0.2, while for Quaichon is 0.5. So that's one of the many points possible here. So we can draw infinitely many points here, and all of them are possible choices as long as they are within the box we set. Now, the condition that we want to satisfy is that the sum of the squares of their values must be less than 1, because we want Quaichon to win. And Quaichon will win if the sum is less than 1. So the condition we want here is x squared plus y squared is less than 1. Now recall from your analytic geometry class that this case has a boundary line that is x squared plus y squared equals 1. And that boundary line there is, or boundary curve to be more formal about it, that boundary curve is a circle with radius 1. Since it has a radius 1, we will be considering this as a radius 1, this as a radius 1, this as 1, this as 1, which would give us a circle that is inscribed in the square we initially set. for us to have a value that is less than 1, the area that we are, or the region that we should consider, is the set that is within this circle. If we are looking for the set that is x squared plus y squared greater than 1, then we would be considering the area outside this one. So in this case, we're looking for the probability that the point we choose is within within this unit circle that we have. Using the concept of geometric probability, that probability is just equal to the area of the circle divided by the area of the square. This is quite analogous to our notion or concept for discrete probability, in that we define it as the number of desired outcomes divided by the total number of possible outcomes. In this case, the desired outcome is the area of the circle, and the total number of outcomes is the area of the square. Now we can calculate this quite easily, because we know the area of the circle to be pi r squared, and the radius of the circle is 1. So this is pi times 1 squared in the numerator, while for the denominator, we have this side length as 1, or this part as 1, and the other one is 1 as well. Therefore, this entire side here measures 2, which is just equivalent to 1 minus negative 1. We know that the area of the square is side squared, so the area of the square with side 2 must be 2 squared. Therefore, the ratio here is equal to pi over 4. And therefore, the probability that we're looking for is equal to pi over 4. And that's our final answer. Again, what we did here is we translated the given problem into a geometric probability problem, where the probability is equal to the ratio of the area of the circle and the area of the square. This is the probability that Quaichon will win. If the question is instead what is the probability that Allen will win, we just simply subtract this value from 1. So P, Allen wins, equals 1 minus pi over 4. Essentially, if we use the same concept here, that will be equal to the area of outside divided by area of square. The area outside must be the area of the square minus the area of the circle, so that's 4 minus pi divided by 4. And that's of course equal to this value as well. So I hope you learned something from this video. Thank you for watching, and if you haven't subscribed yet, please consider doing so. Thank you very much, and till the next one. See ya.